Okay, today we are going to talk about quantifier in discrete mathematics. Quantifier. So in discrete mathematics, there's two types of quantifiers. They are the existential quantifier, existential quantifier, which is denoted by inverse E, and then there's a universal quantifier, which is denoted by a BQ. So the inverted E will be only in mathematics it means there exists, and then the BQ means for any. So BQ is for any, and inverted E it does exist. Now let's give an example about both of them. Okay, so the BQ I belongs to I. It's equal to every element of S such as there exists an index I. I mean, there's index I. Lowercase I is an index I. Belongs to capital big I, which is a set of all indexes such that all the elements or all the X elements belong to the set of S. And a big set of sets contains all the elements I belongs to the big set of I, which is the big set of all the indexes. And the small I, it's one element of index. This is a number. And this is of course the set of let's see, all the numbers. Let me think about it. So me think about that later. Okay, where is an exercise? For all x's belong to all the natural numbers, x squared, the number, all the number that have one multiple of themselves, all the number that are multiple of themselves are bigger than 0. Because x squared could be 1 times 1, it could be 2 times 2. So they're all multiple of themselves. So B is for all x's that belong to P of the set of the number belongs to Q. And there is an empty object that is a subset of A. This is an empty set. This is an empty set actually. Say there exists a, a number n that belong to all the natural number belong to n such that for all n, this is for all that belongs to all the natural number n, n times n multiplied by n equals n. So the exercise is to give the negation of each statement. Okay, let's solve this problem. So the negation of A will be so let's start with for all x that belong to the natural number R such that x squared the number all the numbers are multiple of themselves bigger than 0. So we negate for all x belong to R x squared bigger than 0. And if this will become, this will negate for all x such that now the reason this works is because of that formula is equals to not x. Okay, and let's see. Yeah, this comes for this step right here. That's why we got the third step right here. So for the next step, such that okay, b for all x empty such that oh, so let's solve for all x belongs to the p to the all elements belonging to q such that empty set is subset of the set A. So we negate this whole expression belonging to P of Q such that the empty set smaller R is a subset of the set A. Mm, okay, because we negate this sign with for any x, it will become the x is x. This will be still the same even though it is negated because empty set negate with the empty set is still the same. And yeah, it will actually be the same. Yeah, that would be the solution. Oh, and the reason this work is that here it means there exists. Like for all, this means for all x. For so if it's not for all, is the it will be Therefore, O is not the same as the X6, which is why they're exactly the opposite. So for C, there exists M such that natural or the natural number of N such that for all N belongs to or the natural number belong to N such that all the numbers M and all the number N equals to N. So if we use the negation of there exists N such that for all N that will be for all M that belongs to N such that there exists N and then we get N equals N such that M times N is not equals to N. And that'll be the answer. This also can be another possible answer. The X belong to P of Q such that empty set is not A. This is also another answer. So the negation right here. So those are the same thing.